All right, Harmony Science Academy, Algebra 2. We're going to be looking at this new material, adding and subtracting radicals. Okay, but to your benefit, we're going to look at the warm-up again for an important reason, specifically so you're better prepared for the CBA. So these two examples are very special for the CBA, okay? All right, so we worked with stuff like this yesterday, but these two scenarios are special for the CBA, okay? So anyways, notice, unlike what we did yesterday, that here, we don't have the parentheses like we do here, okay? So that means that this exponent, rational exponent, this fraction exponent, applies only to the x. Okay, that's what's different than the ones we looked at. So we would have 7, and we're going to have x to the 4th, and this is the index of the radical. Okay, all right. So we can go ahead and break it up, okay? But it's obvious we're not going to have 9x's, so we're done. This is, okay? Here's what I mean. If we break it up, I need to circle 9, and I don't have any. So this is the final answer, okay? So this is very beneficial for you guys. So simplify this. There it is. Okay? All right. Let's go ahead and jump to this one. This one's got a lot more going on. Okay. So yeah, we dealt with rational exponents, even the negative. But look at this in here. Okay. We did not have a situation like this, so this one's going to be very valuable. Okay, so let's go ahead and apply what we know this negative does for us. Okay, which is 1 over 16 a to the negative 5, and here we have the 4/5. Okay, all right. Now, in this situation, we have this other negative exponent to deal with. Okay, so the question is, what would be the appropriate next step? Now, although there's different approaches, the best thing to do is deal with these negatives immediately. So here, okay, we know that this exponent is going to distribute to him and to him. Okay, so this is how we're going to play this game. This guy's going to come up, or maybe I should write it like this for some of you guys. I'll go in green. We're going to now have 16 to the 4/5 times, I guess we can put this in parentheses, a negative 5 to the 4/5. Okay. Now, notice what's going to happen here. Once again, we have a negative exponent, so we're going to flip again. All right. So this guy's now going to come on top. A to the 5th, 4 to the 5, over. He stays on the bottom. Okay. 16 over. All right. So everything we applied yesterday is happening here. The only thing is we didn't see this kind of double negative scenario. Okay, that's why it looks different. So anyways, now that we're here, we can continue doing what we know how to do, which is turn this rational exponent and this one into radicals. Okay, so let's do that. We're going to go ahead and up on top we have a to the 5th to the 4th radical. I guess we can put an equal sign here. Equals. So this is now this. This one will be 16 to the 4th. And, whoops, sorry about that. We have index 5 and the radical. Okay, same thing here. So let's go ahead and take care of business here. We're going to go, there's 5 of them. Okay. And again, since we're keeping the same program, let's just not change anything up. I need how many? 4 of them? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the last one. Okay. And down here, I have the 5th root of, what are the factors? 2 times 2 is 4, times 2 is 8, times 2 is 16. 4 times, okay? 1, 2, 3, and 4. Okay. So let's go ahead and do what we know how to do. I'll use this index to circle the factors that repeat 5 times. 1, 2, 3, 4, 5. 5, 5, 5. Okay, that was easy. Here it's a little different. Okay, that's why we're not changing anything up, because sometimes it's not super easy. So we only have 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this guy's left in there, so this is going to equal 1, 2, 3, 4, a to the 4th over 1, 2, 3, which is 2 times 2 times 2. And I guess I'll go a little slower up here too. A. 2, 2, 2, and then there's this last guy here, okay? So 5th of 2. So this is going to give us a to the 4th over 8, 5th root 2. Okay? Alright, so let's go and move on here. We are going to be adding and subtracting radicals. This is what it'll look like. This is our vocabulary, like radicals. Radical expressions that have the same index and radicand. Okay, so let's say I have to add 2 square root of 3 plus 3 square root of 2. I cannot do that, okay, because I need to have like radicals to add them or subtract them. Okay, that means the same index. They do have the same index, a 2 and a 2. And the radicand must be the same. The 3 is not the same as 2. Okay, so this one I would leave it 2 square root of 3 plus 3 square root of 2. Okay, I cannot do this one. Let's come up with an example that I can do. Okay, so let's say 2 square root of 2 and 3 square root of 2. Let's subtract those. Okay, again, I need to check, do I have like radicals? Same index, a 2 and a 2, and radicand, a 2 here and a 2 there. So what I'm going to do then is 2 minus 3 is negative 1, square root of 2. Okay? It's the same thing as 2, those of you guys who like these types of expressions. Can I subtract 2x minus 3x? Yes, because they have the same variable to the same exponent. So 2 minus 3, negative 1x. Okay? Over here, we would imagine something like 2x plus 3y. Can you combine those? No. So we would be left with 2x plus 3y. We could not simplify that further because it's not the same variable. Okay? That's kind of the game that we're playing here. So let's go ahead and get started. So the good thing about these is you guys already have the skills to factor the radicand pretty quickly, and if not, you've got the calculator. So let's go ahead and do that here, okay? So I'm going to have 2 for number 1, and in here this is basically 4 times 12, so 2 times 2, 12 is 2 times 2 times 3, okay? And plus 3. This is 2 times 2 times 3 plus 2. If, again, you need to factor the tree somewhere separately, that do it and then plug it in like this. Okay. This is 4 times 7, so 2 times 2 times 7. Okay. So I need to investigate after I simplify, do I have like terms? Okay. So anyways, here's the index 2, 2, 2. So I'm going to go ahead and circle the factors that repeat twice in each one. Okay. So I'm going to have here 2 times 2 times 2, square root of 3, plus 3 times 2, square root of 3, plus 2 times 2, square root of 7. So this gives me 8 square root of 3 plus 6 square root of 3 plus 4 square root of 7. Okay. As you guys can see, these two terms have the same index and the same radicand, so I can add these. This one, same index but different radicand, so he's going to be separate. Okay. 8 plus 6 is 14, square root of 3, and plus 4 square root of 7. You cannot combine that further. We're done. Okay. All right. Let's get to 2 and call it a day here. Okay. All right. So let me get some space going here. So negative 4. This is 9 times 10. So if you can organize them in your head, again, do the little tree somewhere on the side, okay? So that's going to be 2 times 3 times 3 times 5 plus 5. Okay, that's a big number. What's that? 25 and 10. So that's 2 times 5 times 5 times 5 minus 3. And that's just 2 times 5. Okay? Alright. Now here's the secret for the CBA. These kinds of problems, these adding and subtracting, only involve index 2. Okay, the root or the square root basically. So we're going to keep it consistent and not overcomplicate it in this case. Okay. Alright. So anyways, because the index is a 2, I'm looking for factors that repeat twice. Okay. And now let's go ahead and do what we do. whoops, times 3. I'm going to put the 2 and the 5 back together. Okay. Plus 5 times 5. And I'm left with a 2 times 5 inside, which is a 10. Minus 3. Nothing came out, so we'll put it back together, a 10. Okay. Here we have negative 12, square root of 10, plus 25, square root of 10, minus 3, square root of 10. So if I look at each term, I see that they have the same index and the same radicand. So all of them will come together. So this and this is 13, minus 3 is 10, so I get 10 square root of 10. Okay? After this, we get some practice. Appreciate your time.